Okay. Uh, Good morning, students. See, we have missed out some of the time. We started Educator channel in the Corona period, but we have missed some of the time. And let us be back on this Educator channel, and we'll discuss today one of the cryptographic technique, that is a transposition technique. Let me introduce you what is cryptography. Cryptography, as I say, it's a science of encryption and decryption. Okay, and in simple terms. So let us understand the first what could be a encryption technique. A simple encryption technique could be a substitution. Now let us understand what is substitution. See, consider a message as uh, secure. Consider a message as crypt. Okay, so suppose this is the message. Now replace the letter C with D, R with S, Y with Z, P with Q, and T with U. So this could be one of the encoding or the encryption of this original message, which is a plain text message. We represent it with P, and this is a cipher message or the encoded message. We represent it with C. Now the key which is used in this is +1, means a simple substitution of the letters of the of the letters of the plain text has been done, and this substitution is done with the key with one place ahead in the English alphabet position. Okay, so for example, C is replaced with D, which is D is one letter ahead in the alphabet positions in the English language, and R is replaced with S, Y with Z, P with Q, and TU. Okay, now based on this pattern, we could have how many total substitutions we could have. See, there are 26 alphabets in the English language, so we could have only 25 alphabets, because one is the message itself, so we are effectively only 25 different substitutions. Now this is very simple to break nowadays, because only 25 substitutions are there, so a simple machine could break it, applying the brute forcing means exhaustively trying all possible keys one by one. It could be breaked. Now let us understand. Okay, now this substitution technique is very simple to understand, but let us understand what is transposition technique. See, you would have heard about this word transposition in your mathematics also. Transposition of rows and columns and matrix. We form transpose of a matrix by interchanging the rows with columns and columns with rows. So this is the mathematical, but this from this mathematics it has been taking the name also, the transposition. The concept is very similar to the actual matrix transposition. Now let us take one example of the plain text message, which is cryptography, okay, is secure. Now this is the message, cryptography is secure. Let us apply transposition technique onto this message. Now consider a password as teacups. Teacups, this is our password. Now in the letters of this password teacups, assign the relative position of the alphabets in this password, and relative position means the letter A has the position 1 in the English alphabet, and relative to it the next letter C has the position 2. This is actually the relative position in the English alphabet, okay, not the actual position, because actual position of C will be 3, but according to the letters in this password teacups, the relative positioning of the letter C is 2, and for the letter E is 3, and on the same patterns, and the next letter in the sequence will be P, then S, then T, and then U. This is the relative positioning of the letters of the password teacups. Now let us write this plain text message according to these columns row wise. Let us write it row wise, like crypt. Oh, we write up to the last column, which is to column number 5, according to the means position, this is column number 5, but according to the number it is column number 7. So we write it the masses row wise distributed in columns. Okay, this last the last letter of the message is finishing at this position, this column number, which is column number 4. Now we have distributed this message. The total number of rows have been 3 and total number of columns are 7. Now we have written this message row wise, row and column wise, and we have written this continuously in rows. Total number of rows are 3, which is according to the message. If the message will be long enough, then it will be constituting in more number of rows. Now let us generate the ciphertext for this. The ciphertext is generated by taking the masses in the columns and according to the ordinal position of the letters, ordinal position of the columns. Ordinal position means the first position of the column is 1, then this is the second column, third column, fourth column, fifth, sixth, seventh. So according to the ordinal position of the columns, we extract the masses in the rows. So the first column is this, and the letters under this column is YPC. So this is cipher, means first 3 letters of the cipher is YPC. Now second column is this, so we extract again. So the message will be PHU. Next third column will be RAE. Okay. Next fourth letter is OIE. Okay, and then GS. This particular column has one short letter. It has only 2 letters, means it is a pair of 2 letters only. In the 6th column we have CRS, and in the 7th column we have TYR. Now this is our ciphertext. We write these groups of 3 or the 2 letters in sequence, one after another, means YPC, then PHU, RAE, OIE, GS, CRS, TYR. So this becomes the our ciphertext. Okay, so now as you can see, this ciphertext is very difficult to break, because here the same letter of the plain text could have different letters substitution in the ciphertext. Same letter C at one position would have a different encryption, and the same letter C at different position in the plain text will have a different encryption letter. Okay, so this is a difficult cipher to break, because if you consider the groups of 3, then total number of substitutions, according to the substitutions, Y could be substituted with total number of characters. Total number of characters are there. See, 3 rows are there, and total 7 columns are there. So 3 into 7, 21, and 1 short than 21 is 20. Means 20 letters. So Y could be replaced with 20 letters, P could be replaced with 20 letters, and C could be replaced with 20 letters. So total number of, if the group is of 3 characters, then total number of trigrams, you can say 3 letters group we can say in the cryptography is trigrams. So one trigram would have to be analyzed with 20 into 20 into 20. Total number of these many total number of diagrams would have to be analyzed. So you can understand, in the substitution cipher there were total 26 combinations that you would have to try for exhaustively finding out the key, but here you have to try 20 into 20 into 20 total letters in order to guess the actual plain text. And to make this transposition technique even more complicated, we could apply this process repeatedly. For example, the ciphertext that you have obtained, this ciphertext, again place this ciphertext row wise distributed in columns in this matrix, and again extract them according to the ordinal position of the columns. You will get a more complicated cipher. Okay, so this gets complicated as soon as we form the masses in more than one rounds.